So autonomous vehicles feel new to most of us, as if we haven't heard much about them, but they've actually been in progress for quite some time. So the technological aspects of the development of the vehicles have been tinkering away in the background for decades. And if you think about the way that your vehicle works today compared to what your parents might have experienced, even the fact that they probably drove a manual and you drive an automatic vehicle now. So we've been seeing progressive improvements, even down to your airbags pop up automatically now if you have an accident. But we have cruise control. We've got little devices in the car that centre us in the lane if we want to use those kinds of devices. Some cars are capable of self-parking. Others flash and indicate to us when we're getting too close to other objects. So incrementally, we've been increasing the amount of autonomous content within a vehicle. It's just a matter of time till we take that extra leap and the vehicles become fully autonomous, which means that we won't need a steering wheel, we won't need brakes or accelerators. The vehicles will do all the driving for us. They will be GPS based, so we just tell them either verbally or program it in where we want to go, and the vehicle will be capable of taking us there. So that's kind of like the end goal, and because the vehicle will be talking to lots of other vehicles, it can assess the extent to which there are blockages in traffic and pick different routes depending on the fastest possible available route available at that point in time, depending on how other many road users there are all trying to get to the same place. So it really will be interesting times once we move to the other end, the full end of the autonomous spectrum. At the moment, we have the capability for vehicles to be autonomous, but there are kind of constraining factors that are preventing that from happening right now. And one of the major ones is the fact that we've got hundreds of road rules, all of which specify the driver. So until those road rules can be changed, we're still going to be in a situation where we're not allowed to drive autonomous vehicles in full autonomous mode. However, within the next 3 or 4 years, we're looking at sort of certain precincts probably being able to do that. On Curtin campus, for instance, we have our autonomous bus, and that's allowed to be in autonomous mode because of the fact that it's largely on private property. So we'll kind of see individual areas, geographical areas, introducing autonomous vehicles first.
Hi, I'm Paul Nichols. I'm the Director of Strategic Projects, Research and Development here at Curtin University, Perth, Western Australia. This is KIP, our AV bus that we've had operating for about 3 months now on the Curtin University campus. The bus is called KIP after the Curtin University namesake, Sir John Curtin. KIP was the name of one of his dogs. Curtin's purchased an AV bus because we think it's a great way for us to trial these sorts of disruptive technologies. The same as mobile phones have disrupted the way we operate, and the internet has created all of these opportunities to do things differently. An AV bus can really disrupt the way that we operate in a community.
In terms of when we might look at having loads of different autonomous vehicles on the roads, they say by about 2040 we may have around 3/4 of vehicles in fully autonomous mode. So I think we can see quite rapid adoption of autonomous vehicles coming up in the future. But this is also an evidence-based proposition, if you like, because if you think back to the early 1900s when the motor car was first introduced, we've got the situation where in New York City, for instance, in the year 1900, you had the main street with one car and all the rest being horse and carts. 13 years later, we've got the situation where there's one horse and cart surrounded by motor vehicles. So even back then, in the space of 13 years, there was complete saturation of a new disruptive transport technology. So if we extrapolate that out now to the 2000s, and we're even more receptive to new technology, it's going to be more affordable relatively than it was back then. I think we're looking at really fast adoption rates. The future with autonomous vehicles will look very different to it the way it does now. So in the interim period, we'll probably still have things like traffic lights, but the flows should be much better. Ultimately, however, we're looking at a situation where there are no traffic lights, and those vehicles down to the millimetre can be pinpointed. They'll be each talking to more than 30 satellites, as well as communicating with each other. So they are perfectly well programmed to be able to mix in with each other, again down to the millimetre. So you're looking at a situation of intersections without traffic lights and traffic just merging. So you'd have traffic coming from different directions just blending it and keeping on going. And I know that's a difficult concept to get your head around, but longer term, that's the computers are very well set up to be able to do that. So for instance, traffic control at the moment for aeroplanes already does that. We have the aeroplanes in the sky on automatic pilot for much of the flight, and we have computers determining when and where they're going to pass other flights and when and where they're going to land. So we do put our faith in these machines in some areas. It's just going to be a matter of transferring that to motor vehicles and getting used to that new system. The logistics around that, of course, are interesting because we're looking at a situation where all the frequencies have to be the same. So all the vehicles have to be talking to each other on the same frequency. If only one vehicle has its GPS out by a few millimetres, it could create absolute havoc. So we really need to have the system set up well enough so that they're talking to each other with perfect compatibility, that all of those vehicles are registering their location in exactly the same way and are able to communicate that to each other immediately. We'll have lots of spin-off benefits from that as well. So the vehicles, as well as having their own sensors that can tell them what's in the immediate environment, they can tap into what other vehicles are sensing. So if there are potholes, if there are road signs missing, if there are roadworks, the vehicles can immediately communicate that to the network rather than each individual vehicle having to learn each time it passes by that particular scene. We can have huge savings in terms of trip times. So we're very much looking at a blended system in order for it to be as efficient as possible. It would be quite inefficient if every individual wanted to own their own autonomous vehicle. We would just end up with a whole bunch more vehicles on the road. So for instance, your vehicle would drive you into the city in the morning to go to work. It would turn around and drive itself home again or take itself somewhere else to recharge. It would then come and collect you in the evening and take you home. So rather than that vehicle just being on the road while you're in it, it's now also on the road for quite a while you're not in it. So multiply that out by the number of people in the population and there's the potential for increases in congestion instead of decreases. So we're very keen for public policymakers, our governments, to be proactive in this space to make sure that we encourage the rollout of autonomous vehicles in such a way that we do prioritise public transport. So we've got really good, efficient public transport that runs autonomously, as well as those backup last mile, first mile services that can help people so they don't have to actually own a vehicle, but they can still get really good transport to and from. And then to have the own individual autonomous vehicle as the backup, as the last thing that you would consider.
In the future, Curtin University hopes to have a range of autonomous vehicles operating across the campus. It'll help improve the experience of our students and the guests to the campus, but also improve their safety. Over time, we expect that the level of autonomy of these vehicles will actually improve to the point where we can take our technicians out of the system and where we can go fully autonomous on the campus. The vehicles, we hope, will be able to identify where students are on the campus that need to be moved and actually optimise the movement of those students across the campus.